But before I dive into trucks, I want to spend a little bit of time on cars. To a certain extent, whatever you decide to do in this room about trucks will have almost no impact on the development of the technology, from the standpoint that the massive driving forces that's going on here are all about passenger cars, and more specifically about the accidents involved with passenger cars. Let me explain. So, each year, just in the US, 9.5 million vehicles involved in about 5 million accidents. 2.2 million people injured, 240,000 people hospitalized, 34,000 killed each year. Those are very compelling statistics. A tremendous cost in terms of human pain and suffering. That's what's driving the development of this technology. And it's just not a social driver, it's also a political driver and an economic driver. Because the economic costs associated with those deaths in the US, and 1.2 million deaths worldwide, 50 million people injured, is a tremendous motivator for those various stakeholders who otherwise might move more slowly on the development of this technology. So the economic costs of those statistics just in the US, Morgan Stanley issued a report recently that estimated it at about $490 billion in terms of the direct injuries, property damage, and opportunity costs due to accidents in just the United States, $488 billion. And the costs don't stop there. When you look at the possible fuel savings that are possible with this technology, Morgan Stanley estimated that on the order of $170 billion when you take a look at both the fuel savings when you're driving and the fuel savings by reducing congestion. Productivity savings on the order of $650 billion. Those are staggering numbers, $1.3 trillion in terms of potential savings if you could move to large-scale adoption of autonomous vehicles. So as I say, it's really about the cars that are driving this. But the technology spun off from the development of the cars is the great opportunity for you. Right? Because what's being developed in cars are almost completely applicable to trucks. And to a certain extent, it's more applicable to trucks because you spend most of your time in more predictable driving environments than passenger vehicles. Right? In passenger vehicles, the hard problem is local and urban driving. You spend more time on interstates. The interstate problem is being addressed first and more readily than the local driving problem. So there's an opportunity for the freight and transportation industries to adopt this technology faster. There's also a stronger economic incentive for you to adopt it faster because you can quantify the benefits. So if on average a passenger car driver gets into an accident every 500,000 miles, well, that's not a direct incentive for me to go out and buy a driverless car. But you log many more miles and you understand the economics of these kinds of savings in your context. So that same Morgan Stanley report estimated the potential savings for trucks. And the numbers are still pretty staggering. Much less than the $1.3 trillion we talked about for cars, but $170 billion when you factor in potential labor savings, fuel efficiency gains, productivity gains, reductions in accidents. The annual costs in the US, potential savings, at the steady state of large-scale adoption. Now, of course, we're not going to get to the steady state of large-scale adoption immediately, but those are the riches that are going to be competed for by those people involved in the industry. In other words, you.